Okay, so now we're going to move on to part B, and there are steps to balancing a redox equation or reaction using half reactions. So that's what we're going to do. And we're going to start first off by identifying the oxidation numbers. So aluminum by itself is always just going to be neutral, so put a 0. Same with bromine, because it's bonded with itself, and it carries no charge. Now, in order to form aluminum bromide, we had a cation aluminum and an anion bromine that caused them to come together. So in the rules, we know that anything in the halogen group is a -1 if it's not bonded to oxygen. So bromine has a 1 negative. Now bromine has 6 of them, so it's actually going to be a -6, and the whole thing has to equal 0. So that means if bromine has a total of -6, then aluminum has to be a +6. And we have 2 aluminums, so this is going to be a +3. Now if we looked at the periodic table and we looked at the oxidation numbers on the periodic table, anything in group 7A, which is a halogen, would make a -1, and anything in group 3A would make a +3. So that one follows the rules that we already learned in this class pretty well. So now we're going to write the half reactions. So we'll start with aluminum. So, oh, and there are no spectator ions in this one. I will do one with spectator ions in a minute. So our half reactions. So we have aluminum, which is neutral, and if aluminum is going to become positive, that means it had to have lost some negative charge. So it's going to lose electrons. So aluminum 3 plus 3 electrons. So now our charges are balanced. We have 0 on both sides, and we have, my aluminum, and we also have 1 aluminum on both sides. So the equation is balanced. And it lost electrons, so we would call this one Leo, so loses electrons, oxidation. So this one is an oxidation. Okay, now we're going to do the bromine reaction. So we start with bromine, the diatomic molecule. It's a gas, and it's going to become negative. So in order to become negative, you have to add electrons to it. But we need to add 2 electrons to end up with 2 negative bromine ions in this oxidation reaction. Now this one, it gained electrons. So gained electrons reduction, GR. So this is reduction. Now, we want our electrons to cancel out when we add these 2 half reactions together. And so that means we have to have the same number of electrons. So I'm going to take this equation, and I'm going to multiply by something that will give me the same number of electrons. So if I multiply this one by 3, and I multiply this one by 2, I should end up with 6 electrons and be able to solve the equation and eliminate those electrons, or add them and eliminate all the electrons. So here goes. So I like to write 2 aluminum yields 2 aluminum cations plus 6 electrons. And then I really like to keep my arrows lined up when I do this so I can see what's on the left and the right. So then I will come over here and I'll write 3, oh that's bad, try again, 3 bromine molecules plus 6 electrons will yield 6 bromine ions. And then I'm going to take this and I'm going to add the 2 equations together. And since the electrons are on 2 different sides of the equation, I'm going to cancel the electrons out. And then I'm going to write what I'm left with, which is 2 aluminum plus 3 bromine diatomic molecules, which will yield 2 aluminum cations plus 6 bromine anions. Okay, now we're almost done. The last thing we have to do is we're actually going to put those anions and cations together is what we're going to do to finish this off. And if we have 2 3+ charges and 6 negative charges, then they will just bond just fine together, and we're going to change it to subscript. So here it goes. So 2 aluminum plus 3 bromine yields aluminum 2Br6. And this is the balanced chemical equation. You might be saying to yourself, wow, that would have been a lot easier just to balance the equation from the first place, but the purpose of this was to see which one was oxidized and which one was reduced. And we know that the aluminum gave its electrons to bromine in the reaction, and the electrons were flowing from the aluminum to the bromine, and that's, if we had an electrochemical cell, we could actually create electricity from this. All right, thanks for watching, and good luck with 6 and 7.